But what about the outlet line? In general, when the relief gas passes through PSV from a high pressure system into a low pressure system, it's expected to pass at a very high velocity. If the pipe size is small, it can reach sonic velocity and lead to choked flow. In addition, if the PSV outlet pipe is too small, this shall exert a high pressure drop, which shall form a back pressure against the PSV. This is commonly known as built-up back pressure. Also, the flare itself may exert back pressure on the PSV if another PSV is simultaneously open. This is called superimposed back pressure. The total flare back pressure is the sum of both built-up and superimposed back pressure, and all these factors can hinder the PSV from doing its job and protecting the system from overpressure. That's why they should be considered and studied well when we determine the size of the PSV outlet line. The PSV can even change the PSV type. If the valve is expected to face a high back pressure, a conventional PSV may not fit for purpose in this case, and we shall need to consider more complex types, such as balanced bellows or even pilot-operated PSVs. So here, it's highly important to consider the proper sizing of the PSV outlet. In addition, isolation valves at the PSV outlet should be full bore in order to ensure a smooth relieving operation when needed. Also, as the relief gas passes from a high pressure system to a low pressure system, its temperature is expected to decrease drastically, which may cause liquids to form. As explained in a previous video, this may cause a lot of issues to flow regime if the relief piping isn't well designed. So finally, as we consider a slope in the case of PSV inlet line, we should also consider a slope in the outlet line. But in this case, the slope shall be towards the flare. In addition, pockets are also not allowed for the same reason we didn't allow the pockets in the inlet lines, which is to avoid any accumulation of liquid droplets in the flare header.